The objective of this lesson is to organize and interpret data in a dot plot. Line plots and dot plots are interchangeable terms for the same type of graph. Graphs are tools used by statisticians to analyze data. Line plots and dot plots may show the data using a dot or an X over a number line. Line plots or dot plots show the frequency of data. This type of graph should not be used when plotting a lot of data points. There are other graphs, such as bar graphs or histograms, for use when there is a lot of data to organize and describe. Here is an example of a line plot. The data points are placed on the number line. Each dot represents one piece of data that has been collected. The number of pieces of data should be equal to the marks on a line plot. We label the number line to show what measurements or types of data we are displaying. On this line plot, the label of inches tells us that the measurements of the bean sprouts is in inches. We can examine the line plot for patterns found within the data. For example, we can see the highest and lowest values. On this dot plot, 2 bean sprouts grew 0 inches, which is the lowest value, and 1 bean sprout grew 1 3/8 inches, which is the highest value. We can also see that the most common growth of the bean sprouts was 5/8 inches, since the 5/8 mark on the number line has the most data points. We can also see that most of the bean sprouts grew between 3/8 and 1 inch, since that is where most of the data points are clustered. Now let's create a dot plot using the following data set. Our statistical question is, how wide of a wingspan do golden eagles have? We have gathered the following set of data about the wingspan of golden eagles. As we examine the data, we can see that our lowest value is 6 feet and our highest value is 7 and 5/10 feet. Since the data points are written in tenths, we will need to number our number line by tenths, beginning with 6 and ending with 7 and 5/10. We will label the number line feet, since that is the measurement used in the data. Now we will look at the data points. Each data point will be represented by an X on the number line. We will add an X for each data point: 6 and 9/10, 7 and 1/10, 7 and 5/10, and so forth. After our line plot is completed, we can examine the graph for patterns. For example, we can see that most golden eagles have wingspans between 6 and 6/10 feet and 7 and 2/10 feet. The most common wingspan is 6 and 9/10 feet. We also can see some gaps in the data between 6 and 6 4/10, 6 and 4/10, and 6 and 6/10, and 7 and 2/10 and 7 and 5/10, sections of the graph with no data points. This graph shows the variability in the data. The variability shows this collection of data is spread out. Let's create another dot plot. This time, our statistical question is, how many pencils are lost in our classroom each day? The following data was collected. As we examine the data, we can see that our lowest value is 0 and our highest value is 8. The data is also represented by only whole numbers, so we will number our number line with whole numbers from 0 to 8. Next, we will label our number line number of pencils, since that is what is represented by the data points. Now we will place a dot on the number line for each data point. After our line plot is completed, we can examine the graph for patterns. For example, we can see the most common number of pencils that are lost in one day is 5. We can also see that the class loses about 3 to 6 pencils each day. There were 2 days that no pencils were lost, and there was 1 day when 8 pencils were lost. We can also see that we have a gap in the data set for 1 and 7. The objective for this lesson was to organize and interpret data in a dot plot. We met this objective by creating dot plots and then analyzing the patterns in the data shown by the graph.